252 million years ago, on a planet with one supercontinent, one global ocean, and life that had been evolving for nearly 4 billion years, something happened. It took less than 30,000 years to complete. 96% of marine species disappeared. 70% of terrestrial vertebrates disappeared. The only known mass extinction in the history of insects took place. It is the worst event in the fossil record. Earth was almost emptied. The mechanism is still being argued, more than 30 years after the trigger was identified. This is the cold archive. Geologists call it the Permian-Triassic boundary. Paleontologists call it the Great Dying. In the rock record, it looks like an order of magnitude collapse in marine fossil diversity from one bed to the bed above. The best section in the world is at Meishan, in Zhejiang province in southern China. The boundary is visible to the naked eye. Below, a richly diverse late Permian marine ecosystem. Above, a thin layer of clay, then almost nothing for 10 meters of section. Dating the boundary became the central technical problem of late 20th century geochronology. Sam Bowring at MIT and his collaborators began applying uranium-lead dating of zircon crystals at Meishan in the early 1990s.
Burgess, Bowring, and Shen, in their 2014 paper in the Proceedings of the National Academy of Sciences, dated the boundary at 251.902 million years ago, with an uncertainty of 24,000 years.
Their analysis constrained the main extinction pulse to less than 60,000 years. The geological clock is sharp. The kill happened fast. The chemical signature is equally sharp. The ratio of carbon-13 to carbon-12 in marine carbonates drops at the boundary by 3 to 7 per mil, depending on the section. A negative excursion. Something dumped a vast mass of carbon into the system. The carbon was depleted in the heavier isotope. That points to either organic carbon, like methane, or carbon released by intense volcanic activity. The mass involved is on a planetary scale. What was happening on the surface of the Earth at the same time? Across central Siberia, a flood basalt eruption began. Today we call it the Siberian Traps. The preserved volume covers roughly 700,000 square kilometers. Total erupted volume is estimated at 1 to 4 million cubic kilometers of basalt. The eruption began approximately 300,000 years before the extinction and continued for approximately 1 million years afterward. The main pulse overlaps the extinction window exactly. In 2017, Burgess, Muirhead, and Bowring dated zircons from the Siberian Traps directly. The main eruption pulse coincides with the carbon spike at the marine boundary. The temporal phase match is no longer in serious dispute. The Siberian Traps were the trigger. The current consensus arrived at that conclusion in stages between 1995 and 2015. What is still in dispute is the kill mechanism. What did the trigger actually do? The traps injected an estimated 30,000 to 100,000 gigatons of carbon dioxide into the atmosphere. Modern best estimates converge on the higher end. Atmospheric CO2 may have reached 2,000 parts per million, roughly 4 to 5 times the pre-extinction level. Global temperatures rose by approximately 10 degrees Celsius. Tropical sea surface temperatures may have exceeded 40 degrees. The shallow oceans warmed catastrophically. Oxygen solubility dropped. The deep oceans became anoxic.
Wignall and Twitchett, in their 1996 paper in Science, documented the Euxinia signature in the boundary sediments. Deep water columns saturated with hydrogen sulfide, produced by sulfate-reducing bacteria. The deep ocean became uninhabitable.
Warming, acidification, anoxia, euxinia. The kill cascade is broadly accepted. The question is what amplified each step and in what order. 4 hypotheses about the kill mechanism have been advanced since the 1990s. 1 has been rejected. 2 are folded into the consensus as amplifiers. 1 remains a live area of active research. Hypothesis 1, an asteroid impact. In 2004, Becker and colleagues published in Science proposing the Bedout structure off northwestern Australia as an impact crater contemporaneous with the boundary.
Becker and colleagues, 2004, their paper proposed the Bedout High off northwestern Australia as a candidate impact site for a large bolide, an asteroid or comet fragment striking Earth at the end of the Permian.
The hypothesis would parallel the Cretaceous impact at Chicxulub, the constraint that broke it. Subsequent investigations could not confirm Beidut as an impact crater. No shocked quartz, no iridium anomaly at the boundary on the Chicxulub scale, no confirmed crater. The hypothesis is essentially rejected. Hypothesis 2. Methane clathrate release. Kroll and colleagues in the year 2000 proposed that warming from the initial Siberian Traps phase destabilized methane hydrates on the continental shelves, releasing additional methane into the atmosphere. Methane is depleted in carbon-13, which fits the negative carbon spike better than pure volcanic CO2 alone. The hypothesis has not been rejected. It has been folded into the consensus as a likely amplifier of the primary signal. Hypothesis 3. Methanogen biological feedback. Daniel Rothman and colleagues at MIT in 2014, in the Proceedings of the National Academy of Sciences, proposed a biological amplifier that no one had considered before.
Rothman, 2014, a burst of methane production by marine methanogens following a horizontal gene transfer event that allowed efficient acetate metabolism could account for the observed rate and isotopic signature of the carbon excursion.
Ocean acetate concentrations rose as Siberian Traps volcanism increased continental weathering. The methanogens, bacteria-like organisms that produce methane, bloomed and metabolized the new carbon supply at industrial scale. The model accounts for the rate and isotopic signature in a way that pure Siberian CO2 alone does not. It is active research. It has not been refuted. It has not yet been fully accepted. Hypothesis 4. Halogen-driven ozone collapse. Benjamin Black and colleagues at MIT in 2014 modeled the chlorine, bromine, and fluorine release from the Siberian Traps as the magma intruded through Permian salt deposits. Their model predicted significant stratospheric ozone destruction at the boundary. Pollen mutations documented at boundary sections by Vischer and colleagues are consistent with increased ultraviolet radiation. The terrestrial kill may have been UV damage as much as heat. So the consensus reads, Siberian Traps trigger, CO2 release, global warming, ocean acidification, ocean anoxia, ocean euxenia, methane clathrate destabilization as amplifier, methanogen bloom as further amplifier, ozone layer damage as cause of terrestrial collapse. Each of the last 4 mechanisms has at least one paper proposing it. None of them has been formally falsified. The exact order and the exact relative contribution are still being argued. The trigger is closed. The kill cascade is open. The fossil record holds the answer. The fossil record has not yet given it up. 5 mass extinctions are documented in the fossil record. The Permian-Triassic was the worst. Recovery took 5 million years. Some lineages took 10. The mechanism is still being refined more than 30 years after the trigger was identified. 60,000 years to empty the oceans. 5 million years to refill them. We are still reading the record. Wednesday's case. 2% of the residents of Taos, New Mexico, hear a continuous low-frequency hum. Their neighbors don't hear anything. Acoustic analysis has not identified a physical source. Wednesday, 8 p.m. Eastern. See you then.